Roughly every 11 years, our star ramps up to a turbulent state, expelling violent eruptions. After a peak, it calms down to a quieter phase before starting all over again. This is known as the solar cycle. This ebb and flow of solar activity affects the entire solar system, including spacecraft electronics and astronauts that can be affected by particle radiation if they're not sufficiently protected. Understanding the solar cycle is one of the oldest problems in solar physics, and now predicting it is more critical than ever as we venture to the Moon, Mars, and beyond. So here are ways we've learned about tracking it.
So welcome to the dome. Today we're gonna observe the sun and see if it has some sunspots.
Every morning when the skies are clear, Olivier looks through this telescope in search of sunspots. These are dark blotches on the sun that are the main source of solar eruptions. They appear and disappear on the sun's surface.
So we're not looking at the sun, in fact we're looking at the shadow of the instrument. Then we put the paper always at the same place, and then we can start drawing.
Olivier and a team of sun observers record the pattern of sunspots by pencil. The first known record of sunspots date back to around 1,000 years ago in China. After the invention of the telescope in the 17th century, routine observations were made. Today, sunspot drawers still use the same technique. While we've created satellites that can see the sun in much more detail in recent decades, drawing by hand keeps the centuries-long record consistent. The sunspot number record goes back farther than any other instrument, allowing scientists to analyze the sun's behavior over many solar cycles. Sunspot numbers are collected from observatories around the world and are averaged. During every 11-year cycle, the number of sunspots rise from zero to a peak and then go back down to zero again. Scientists use these numbers to determine when a new solar cycle begins and how active a cycle is. Solar maximum, the period of highest activity, can vary wildly from cycle to cycle. The more sunspots there are, the higher the frequency of solar storms of all types. Some that create aurora, and some that can affect power grids on Earth. But sunspot number isn't the only indicator we see. These numbers are often combined with other signs. At the beginning of each cycle, sunspots appear on the sun in the mid-latitudes for a brief few hours to days. At solar minimum, there are often days without any spots at all. As the sun becomes more active, sunspots form closer to the equator and can stick around for weeks to months. These sunspot patterns give clues to what drives the solar cycle, the twisting of the sun's magnetic field. Like Earth, the sun has a magnetic field with a north and south pole. But unlike Earth, the sun's magnetic field becomes extremely complex. This is because the sun is made of plasma, a charged gas that generates electric currents. As the sun rotates, plasma around the equator moves faster than near the poles, causing the magnetic fields to become stretched, elongated, and then twisted. Then kinks in the magnetic fields burst through the surface as sunspots larger than the size of Earth. As the solar cycle unfolds, more sunspots appear and the magnetic field becomes more tangled. At the peak of the solar cycle, the sun's magnetic field flips. The North Pole switches to the south and vice versa. The cycle then ramps down, ready to start a new cycle. Scientists can eventually see the result of this flip inside sunspots using satellites. This black and white image of the sun shows the magnetic field on the surface. Most sunspots appear in pairs. Like a magnet, one side is positive and the other is negative. After they form, they gradually disappear again, leaving behind remnants of magnetic fields that move towards the sun's poles. Eventually, each pole accumulates enough magnetic fields, forcing the sun's poles to flip at the peak of the cycle. Then, new sunspot groups appear with the polarities in the opposite direction. Scientists look for a consistent string of these new sunspots in order to declare the next solar cycle. But the transition between cycles is slow and messy. Cycles often overlap, creating freckles of old and new sunspots on the sun at the same time. Scientists can only determine we're in the new cycle when the number of new sunspots overtake old ones, which can be 6 months to a year after the new cycle has begun. While these spots give us a visible tracker, in recent years, scientists have discovered another signal that's hard to see from Earth. The strength of the sun's poles during solar minimum can help predict how active the next cycle will be. After the poles have reversed at the peak, scientists keep a close eye on it for the next few years. If the magnetic fields accumulated at the poles become strong during this time, it's likely the next solar cycle will be an active one. If the buildup is weak, the next solar cycle won't be as active. While we use these indicators to track the sun, predictions are still hard. After all, we've only had detailed satellite observations of the last 4 solar cycles, and scientists are still learning about what causes the sun's cycle. So until we piece together those missing pieces, the sun, even with its 11-year clock, will continue to surprise us.